differentiation. We were given a nonlinear function and we are told that the gradient at a point is 24. We want to find that point. So the first port of call is A. Well, let me find the gradient function, which is how. And how do we find the gradient function? We find the derivative, right? So dy dx. So it's a composite function, so you multiply the index to the front. You decrease the index by 1, and you multiply by the derivative of inside of the bracket. Right, so you're just going to get 2 by 3 is 6. So we're going to get 6 multiplied by 2x minus 1 then squared. Okay, so far so good? Right, cool. Sorry, what? Yeah. And then we're going to let that equal to 24 because they told us, right? Yeah. Correct. So we're going to let 6 by 2x minus 1 then squared equal to 24. All right, so we could divide by 6 first. So 2x minus 1 then squared is equal to 4. And then we could square root. Hold on, so divide by 6. And we're going to square root. Right, so we're going to get 2x minus 1 is equal to, actually maybe it's points. Maybe it's points, right? 2x minus 1 is equal to plus or minus 2. Because, of course, every square has 2 roots, right? A positive root and a negative. Now, to solve for x, we'd have to add 1 to both. So we have plus or minus 2 plus 1. And then to solve for x, we'd have to divide by 2. So plus or minus 2 plus 1 all over 2. Right, so if we take the positive root, 2 plus 1 is 3. And then we have 3 over 2. If we take the negative root, minus 2 plus 1 is minus 1. Right, so we have 2 x values here. And of course, now to find the y values, what do? We substitute them inside of the original function. All right, so we're just going to consider the positive one just for the sake of simplicity, right? So y would be equal to 2 by x, which is 3 over 2, then minus 1, and then we're going to cube that. So the 2's will cancel, leaving us with 3 minus 1, which is 2. Then you just have 2 cubed, and 2 cubed is 8. So the coordinates of the point are 3 over 2 on the x and 8 on the y. Right, so again, they gave us a function. They told us, hey, the gradient is 24 at some point. What's that point? So once we're dealing with a nonlinear function, a curve, and dealing with gradient, you have to find the derivative. So we found the derivative using the chain rule for composite functions. We let that gradient equal to 24, and we solve for x. And we only consider we found 2 x coordinates, but we ignore the negative one for now, just for the sake of simplicity. Right? But most times if they ask for points, they use both. I just kind of run out of space, that's all. Right? And after you found the x coordinate, you substitute it back up inside the original function to find the corresponding y coordinate. Yeah? Yeah? Okay. All right, Drew, just give me a quick G or a thumbs up if you're good with that example, please, and thanks.